Question number 13, CY 2013. And the question is, find the catalyst and co-catalyst used in the Waker process. Now, there are four options given. First, option A, PDCl2 and copper, where PDCl2 is catalyst and copper as co-catalyst. Similarly, option B, cupric chloride and PDCl4 2-. Again, CuCl2 is the catalyst here and PDCl4 2- is the co-catalyst here. Option C, palladium and cuprous chloride, where palladium is catalyst and CuCl, cuprous chloride, is co-catalyst. And last, option D, PDCl4 2- and CuCl2, where PDCl4 2- is catalyst and cupric chloride is co-catalyst. So you have to choose the correct answer among these four options. Now coming to the answer. It is an easy question. Just we have to find out the Waker process. If we write down the Waker process, then we can easily find out which is the catalyst and co-catalyst. Which is also called oxidation of alkenes to aldehydes. So this is an oxidation process from C11C to CH to CH double bond O. That is an aldehyde. Another name of the reaction is Schmidt reaction. So now we have to draw the Waker process or the oxidation. So first, starting with PDCl4 2-. Two- charge. Now 1 molecule of alkene is added to the system and 1 chlorine chloride ion liberated. So it will give since 1 chloride ion is liberated and there is no charge in the alkene, thus the total charge is -1. Now 1 H2O, or more or less it is a solvent molecule, is added and another chloride ion liberated. So the fate of the complex become since palladium is 2+ charge and 2 chloride, both OH2- both OH2 and the alkene doesn't have any charge. This is a neutral one. Now what will happen? One of the proton from this uh, uh, coordinated water is liberated and the compound will become and since OH has -1 charge, so it gain total charge of the complex become -1. Now another molecule of water, or you can say solvent, will be added to the complex, and what will happen here? Because of the addition of water, this OH will move from palladium to the carbon of alkene, and the complex will look like after this. Okay, now the next step, this is the RDS, or RDS means rate determining step. What will happen? This water molecule will be liberated, and along with this liberation of water molecule, see here that CH to CH2 linkage, what we can do, we can put one proton here. So this is alpha position and this is beta position. So this beta hydrogen from the CH group will migrate from alkene to palladium with the liberation of water. This is kind of beta migration. And insertion, where it is inserted onto the palladium. Now the fate of the complex become look like okay. Now this molecule will be rearranged because this proton, so this proton can be decimized to and move from uh, oxygen to another carbon of alkene. Thus, the complex after this rearrangement will look like this. From here, reductive elimination will happen and it will form this compound. So this is actually the process from CH2 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 double bond CH2 to CH2. So this is actually a process from CH2 double bond CH2 to CH3 CHO, and your final compound is formed. So this is the main Waker process, or the catalytic cycle. So this is your main catalyst. Then how we will regenerate the catalyst here? So this is from HPDCl2 minus. We have to regenerate PDCl4 2 minus from this one, and it will be done by this follows. The HPDCl2 minus will break down into this. Now this palladium 0 will be changed to PDCl4 through a co-catalytic. And what is the cycle? Look, PD0 plus CuCl2 plus 2Cl minus will give PDCl4 2 minus plus 2CuCl. Again, this the precipitate of CuCl will be transformed into CaCl2 by this reaction. So this is your co-catalyst. So this is the whole Waker process. So this one, your catalytic cycle. This is your main catalytic cycle, and this is your co-catalytic cycle. So your catalyst is PdCl4 2- and co-catalyst is CuCl2. So you find your answer now, which is the option? Option D. This is your answer. PdCl4 is a catalyst and CuCl2 is a co-catalyst here. For further reference, you can look into the lecture on olefin oxidation reactions by Professor Prosenjit Ghosh, Department of Chemistry, IIT Bombay. And this is the required YouTube link of that video, of that lecture. Thank you very much.